Hi, geometry. Let's talk about review number 2. So first off, I hope you change the equation to negative 2x squared plus 12x minus 16. So first of all, I want to find the vertex. Anytime it's in standard form, to find the vertex, my x coordinate is going to be equal to negative b over 2a. So let's do that. I get negative 12 over 2 times negative 2. That would be negative 12 over negative 4. So it looks like I'm getting a 3. So that is the x coordinate of my vertex is a 3. And I know my axis of symmetry is going to be x equals 3. I'll talk about that after I graph it. And I need to find my y coordinate. But if you know your x coordinate, you can just substitute it in to find your y. So my y is going to be equal to negative 2 times 3 squared plus 12 times 3 minus 16. So that looks like 9 times negative 2, that's negative 18, plus 36 is 18, minus 16. It looks like it's a positive 2. So my vertex is 3, 2. Let's graph that, 3, 2. My a value is this negative 2 right here. So when I think about my 1, 1, 2, 4, I'm going to be multiplying my y movements by my a value of negative 2. So this is going to be down 2 and down 8. So I'm going to go over 1 and down 2. I'm going to go over 1 and down 2. And now I'm going to go over 2 and down 8. So that would be down to negative 6 and over 2. And that's harder for me than it is on the graph paper in the classroom. And so this is my parabola. So now on this next one, it wants the y-intercept. But the problem is I don't see my y-intercept. So the one cool thing about standard form is, I don't see my y-intercept on the graph, but I can see my y-intercept from the equation. It's the negative 16. I know to substitute in a 0 for x. So if I do that, I would get y equals negative 2 times 0 plus 12 times 0 minus this 16. So I know that my y-intercept is at negative 16. So it's the coordinate 0, negative 16. When x is 0, my y is negative 16. Now the x-intercept. So first of all, two things about this. I can see my x-intercepts. They're right in front of me. I can clearly see that my x-intercepts are 2, 0, and 4, 0. So I'm just going to write that down. But this is when you substitute y equals 0. So let's say you couldn't see the x-intercepts. I then would have to solve this. I can do that a couple of ways. So 0 for y equals negative 2x squared plus 12x minus 16. First of all, you could do a is negative 2, b is 12, and c is negative 16, and you could throw that all in the quadratic formula. This also factors, if you took out a GCF of negative 2, you would get x squared minus 6x plus negative 16 divided by negative 2 would be plus 8. So you have a diamond with a positive 8 and a negative 6. So your side numbers are negative 4 and negative 2. And you get your negative 2. And then you would have your x minus 2, x minus 4. And I could set my x minus 2 equal to 0, and that's where my x equals 2 from my x-intercept comes from. My x minus 4 equals 0, my x equals 4 comes from. So now my vertex form. Well, vertex form is y equals a times x minus h squared plus k, where my hk is my vertex. My vertex is 3, 2. This is my hk. So I'm just going to write it. It's going to be x minus 3 squared plus 2. And then my y value, my a value, I meant to say a. My a value is negative 2. I can clearly see that up here. Remember, this is your ax squared plus bx plus c form. So my a is negative 2, so let me slip that in there. And that would be my vertex form. There's been some students asking me about completing the square. You are right. You can find this. You can also find it using that method. That's not one I went over in the classroom. So I would expect you to get this because you knew what the vertex form was. You can look in your packets at page 13. That's the first day that we talked about vertex form. The domain and range. So my domain is my x values, and it's what my x's can be. This parabola is going to slowly grow outwards and downwards forever and ever and ever. So it's going to cover every x value on the x-axis, gradually growing forever and ever outwards. My range, though, since it's going downwards, it's going to be all negative numbers. But notice that my y values end at positive 2. So y equals 3, 4, 5. These are not numbers that are going to be on my parabola. So my max y value is 2. And so it'd go from negative infinity all the way up to 2 on the y-axis. So let's look at this next problem. Let me slide my page up. This is another graphing problem. This one's in vertex form. So I'm going to just grab out that vertex of 4, 2. So let's put a dot at 4, 2. Now my a value is negative 1/2. So when I do my 1, 1, 2, 4, I'm going to multiply my y movements by that negative 1/2. And I get negative 1/2 and I get negative 2. So I'm going to go over 1 and down 1/2 and over 1 and down 1/2. Over 2 and down 2, over 2 and down 2. You could keep going with over 3 and down 4.5, and you could do that if you want, but I'm just going to quickly draw in my graph here. My axis of symmetry is that vertical line going down through the middle of my graph. That vertical line is x equals 4. It's just whatever the x coordinate of your vertex is, and it's a vertical line, so it's always going to be an x equals equation. I can't really see my y-intercept, so I'm going to substitute in a 0 for x. In this problem, when I do that, I have negative 1/2 times 0 minus 4 squared plus 2. That is negative 1/2 times negative 4 squared, which is positive 16. So that looks like it's going to be a negative 8 plus 2. Looks like I'm going to get a negative 6 for my y-intercept, so 0, negative 6. You might have got it from the graph if you kept moving your graph out. Okay, so now my x-intercepts. I can clearly see my x-intercepts. My x-intercepts are at 2, 0 and at positive 6, 0. Now, if I could not see my x-intercepts, so I'm going to set this equal to 0. So I have 0 equals negative 1/2 x minus 4 squared plus 2. So I'm going to solve this by taking the square root of both sides because I'm going to isolate my x minus 4. I'm going to subtract 2 from both sides, and then to keep isolating my x squared minus 4, I'm going to multiply both sides by negative 2. That cancels here. And I get positive 4, negative 2 times negative 2, equals x minus 4 squared. I'm going to take the square root of both sides. And as soon as I take the square root, I do my plus minus. So I get a plus minus 2 equals x minus 4. And then I'm going to add 4 to both sides. And when I add 4 over, I stick it right in front of my plus minus. And so 4 plus 2 is 6. So x equals 6, or 4 minus 2 is 2, or x equals 2. And that's how I can get my x-intercepts. So what about standard form? I'm going to go grab a different color. Standard form, I have to multiply this all out. So I have negative 1/2 times x minus 4 times x minus 4 plus 2. So it's negative 1/2 times x squared minus 8x plus 16 plus 2. Distribute my negative 1/2, and I get negative 1/2 x squared plus 4x minus 8 plus 2. I'm going to combine those two as I write it. So it's going to be negative y equals negative 1/2 x squared plus 4x minus 6. Okay, you guys, my domain, again, my x can be any number on the x-axis, but my y values only go from all the negative numbers, since my parabola points down, and it goes up to positive 2, and then my y values stop. There's no more y's on my parabola, so negative infinity up to 2, and it stops. So let's take a look at this baseball problem. When you're doing this problem, this 2 should be an exponent. I apologize, probably something with my Word docs and Google Docs. Anyways, it wants me to find the maximum height and the time it gets there. Anytime you're talking about a maximum, you know that we're looking for the vertex. The x-coordinate, that's the time, and my y-coordinate, that's the height at that time. So let's do this. My x-coordinate, or my time, is negative b over 2a. So let's do that. That's negative 88 over 2 times negative 16, negative 88 over negative 32, and when you divide those, you get positive 2.75 seconds. So the time that it gets to its max height is 2.75 seconds. To find its max height, I'm going to substitute that time in. So I want to know the height when the t is 2.75. So I've got negative 16 times 2.75 squared plus 88 times 2.75 plus 4. We're going to stick all that in our calculator, and we're going to get 125 feet for our max height. So let's take a look at the next problem. It says Dylan says the y-intercept is negative 4. Oh, no, no, no. So it looks like he was thinking of the standard form, but this is vertex form, so you can't just look at that last number. Remember, to find the y-intercept, this is when I substitute in x equals 0. So let's do that. Y equals 2 times 0 minus 3 squared minus 4. And this is 2 times what? Negative 3 squared, which is 9. So then that's what? 18 minus 4. It looks like my y-intercept is going to be 0, 14 on that one. Okay, so let's take a look at the next problem. So Anna thinks the vertex is 4, negative 6. Oh, no, 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 no. So this is not in vertex form. This is in factored form. So these are my factors. This is where I can find my x-intercepts. If I set this equal to 0, my y is 0, then my x's will be x minus 4 equals 0. So one of my x-intercepts is 4. And my other x-intercept is negative 6. So if I think about that graph, I've got an x-intercept here at 4, 0, and I have an x-intercept here at negative 6, 0. So it wants to know what the vertex is. You've got a couple ways to do this. First of all, one of the ways that we talked about on page 13 is that the vertex is halfway in between my x-intercepts. So between negative 6 and 4 is 10 units. Half of that is 5 units. So here at negative 1, which is 5 away from negative 6 and 5 away from 4, that's going to be the axis of symmetry. I know that the x-coordinate of my vertex has to be negative 1, but I need to find my y-coordinate. So let's plug that in, shall we? So y equals negative 1 minus 4 times negative 1 plus 6. And what am I getting? Negative 5 and 5. And I'm getting, what, negative 25? So my vertex is way, way, way down here at negative 1, negative 25 in my parabola. Sorry, it's really bad with my Apple Pencil there. Sorry about that. Anyways, so that's my parabola. There's another way to find the vertex. You could multiply factored form out to standard form by doing your box or FOIL method. So when I do that, I would get x squared. What is that? Minus 4x plus 6x. So plus 2x minus 24. You guys could do your negative b over 2a. If you did that, you're going to get negative 1. And then you'll plug negative 1 in. And when you plug negative 1 in, you're going to get negative 25 again. So then you're going to get the same exact vertex that I got, thinking about it being halfway in between. So it both worked. I love them both. Okay, you guys, let's see what's on the next page. Okay, so in this one, we're to write the equation of each graph in vertex form, factored form, and standard form. So here's my vertex at negative 2, negative 1. So my vertex form is y equals a times x minus h squared plus k, where hk is my vertex. So this is y equals x minus a minus 2, or x plus 2 squared minus 1. And I can tell my a is 1 because I'm going over 1, 1, and over 2, 2, 3, 4. So that's regular quadratic movement. So my a is 1. I could write that or just leave it. My x-intercepts are -3, 0, and -1, 0. So I know that my factored form has to be the opposite of that. It must have been x plus 3. So then when I set it equal to 0 and solve, I get a -3. And it must have been an x plus 1. Again, so when I set it equal to 0, I get a -1. And I know my a is 1, so I don't have to put anything in front of those parentheses. Standard form, you could multiply either one of these out to get standard form. I'm going to multiply out vertex form, which isn't what I would do normally, but let's say you forgot how to get factored form. So you only have vertex form on your paper. So you're going to multiply this out, x plus 2 times x plus 2 minus 1. You get x squared plus 4x plus 4 minus 1. So you're getting x squared plus 4x plus 3. So now, if you didn't have your factored form, now you could do the diamond method and you could get your factors of x plus 3 and x plus 1. So let's take a look at this guy. I know it's going downwards, so my a is going to be negative. I definitely know my a is a negative number for sure, like -1 or negative something. I'll figure it out in a minute. So my vertex here is 3, 2. And so I know my y equals x minus my x coordinate, which is a 3, squared plus 2. And now I need to figure out my a. I notice I go over 1 and down 2, and I go over 2 and down all the way down 8. Wow. Okay, that looks like I've doubled my quadratic movements. So not only is my a negative, but it looks like my a is a -2. Y equals -2, x minus 3 squared plus 2. So my factored form, I have a 2, 0, and I have a 4, 0 as my x-intercepts. So I know that this must have been an x minus 2 in order to get a 2, and an x minus 4 in order to get a 4 for my x-intercept. And I know my a is -2, so I'm going to stick it out in front. Let's say you were forgetting how to do that. Great, go back to your vertex form. Let's go find standard form. Y equals -2, x minus 3 squared plus 2. So I would have x minus 3 and x minus 3, and I have to do my 4. So we got y equals -2, x squared minus 6x plus 9 plus 2. I'm going to distribute that -2 before I add. So y equals -2x squared plus 12x minus 18 plus 2. So it looks like my standard form is -2x squared plus 12x minus 16. So let's say you didn't have factored form yet. At this point, let me get a different color. If you didn't have factored form, this is where you could factor out a -2. You get x squared minus 6x plus 8. And then you would do your diamond, and this is where you'd get your side numbers of -2, -4, and now you would have it in the factored form that you guys see up above. So judging by our homework quiz, it looks like we were okay-ish on projectile motion. So I'm just going to give a few tips here, but you can look at the answer key for more help if you need it. But this page is pretty much just like page 19 in our packet, just FYI if you need something to look at. What is the height when t is this number? So I'm going to substitute 1.1 seconds in for t. And when I do that, and then I do all my math, that is how I'm going to get 9.04 feet after 1.1 seconds. Wind does have a height of 2. So I'm going to set the height, h of t. I'm going to set that equal to 2. I have -16t squared plus 24t plus 2. So I'm going to subtract 2 from both sides. I get 0 equals -16t squared plus 24t. This is factorable. You could totally get your two answers, 0 and 1.5, I think, by factoring. You could also use a equals -16, b equals 24, and c equals 0 in the quadratic formula, and you're going to get the exact same two answers. you can refer to the answer key for that. When will it have a height of 12 feet? So now I'm going to set my height equal to 12. And I'm going to subtract 12 over, and so I can get it equal to 0. And I get negative 16t squared plus 24t minus 10. And now I have my a, b, and c. When you do the quadratic formula, I believe this is one where you're going to end up with a negative underneath the radical. It just means that it never gets to 12 feet. So you guys do this on your own, and if you need any support, take a look at the solution and come see me if that's not enough. Max height, and when will it be the max height? That's a vertex. So for E and F, you need the vertex. You're going to do your negative b over 2a, and then you're going to substitute it in to find that max height. G, let's draw a sketch. I need a little bit more room, though, to do a sketch. So in order to draw a sketch, I do need to look at the answer key for just a second. I need to figure out what my vertex was. It looks like my vertex in this part, after you do your math, is 0.75 and 11. And, oh, you know what I didn't do? Sorry. I think, okay, wait. This was D and E. D and E is the vertex. That's my negative b over 2a. And then F was, when does it hit the ground? Okay, back up. When it hits the ground, the height is 0. So I'm going to set 0 equal to negative 16t squared plus 24t plus 2. And you're going to have to use the quadratic formula. You get negative 16 for A, 24 for B, and C is 2. You can take a look at my work in the solutions, but you're going to get negative 0.08 seconds or 1.58 seconds. So I know that it hits the ground at 1.58 seconds. So it's hit at 2 feet tall. At 2 feet. I know that because that's my y-intercept. I know the vertex occurs at 0.75 seconds, and it's a height of 11. I know it hits the ground at 1.58 seconds. So I'm going to kind of draw in this parabola. So the blue part is the part that involves my tennis ball, but the parabola, this is where the crossed out x-intercept is, that dotted line. So anyways, the domain and range. So the domain is, for this problem, what value, so this is for my tennis ball. The tennis ball's domain is the time my tennis ball has been hit, and my tennis ball gets hit at 0 seconds, and my tennis ball falls back to the earth after 1.58 seconds. So my tennis ball is in play from 0 to 1.58 seconds when it hits the ground. The range is my heights. The heights of my tennis ball range from 0, being on the ground, all the way up to a height of 11. So my y values vary between 0 and 11. So now let me get a different color. If this was just, forget that it's a tennis ball problem, if it was just a graphed parabola. Well, this parabola, the domain, so I'm going to put parentheses, if just a regular parabola, so not a story problem, then my domain, my x values would be from negative infinity to, parentheses, because it's infinity, to positive infinity, because my x values could be anything on the x-axis. But my y values, let's look at this. My y values would be all these negative numbers creeping up here towards 11 and stopping abruptly at 11. That's my very highest y value. So my y values are everything below 11. So my y values, or my range, would be negative infinity, because you can't contain infinity, so I'm going to have a parenthesis, to 11, and 11 would get a bracket. But again, that's if it was not a story problem. It's a story problem. You want the answers in blue for this particular one. I hope this video was helpful to you. If you have any questions, please don't hesitate to come see me in office hours or bring your questions to class. Thanks.